In this video we will zoom in on one of the inner circles. We will take repair as an example. We all have the experience that products that break down are hard and sometimes even impossible to repair. But what does it mean to enable repair? Here we will provide insights and design aspects that help to improve the repairability of a product. In the next video we will discuss business and user aspects that we also need to take into account. Repair becomes easier if standard components are used. This facilitates that components needing to be replaced are accessible and affordable. Ease and rapid disassembly should be made possible. This can be enabled by providing visual cues for product disassembly. Dividing the product in functional modules can help. Then take care that fasteners are visible and easy to reach, and that they can be handled using common disassembly tools. Further, reassembly should also be easy. This requires at least the use of reusable fasteners. How to approach this? A modular plug-and-play approach is by many seen as ideal, but in reality this is hard to achieve for most products. Further, this assumes that modules will be replaced, but if the modules are large, this just replaces the problem to module repair. Let's look into a more generic approach and take a vacuum cleaner as an example. First, we need to focus on vulnerable components, so-called priority components. Priority components are those that are most likely to break down and cause major functionality loss during the product lifespan. Additionally, components with high environmental impact or high economic value could be prioritized. A designer needs to think about the way in which components are placed in the product and try to optimize the accessibility of priority components. A tool that helps designers to visualize this is the disassembly map. A disassembly map basically is a disassembly tree that clearly shows the number and nature of steps that are required to remove each component in a non-destructive way. Not all the disassembly operations are the same. Some are more difficult than others. Different operations are therefore represented by so-called action blocks. That distinguishes the difficulty of actions by using shapes, colors and shades. This helps to rapidly locate the most difficult operations, indicated by the square blocks in dark red in this example. Based on such insights, a designer can reconfigure the design to reach a better solution. To improve repairability, priority parts should be moved as close as possible to the disassembly surface, implying that those components are easy to reach. Let's look at this vacuum cleaner. The design of the product makes disassembly hard, as is evident from the large number of disassembly steps needed to reach certain priority parts. By grouping the non-priority parts, accessibility of the priority parts can be facilitated. The resulting disassembly map shows that more priority parts are now easy to reach. In this vacuum cleaner, based on analyzing the disassembly map, 4 internal screws were repositioned to cluster components in a different way. This resulted in 60% faster disassembly of the cord winder, 40% faster disassembly of the PCBA, and 40% faster disassembly of the motor. To conclude, mapping of the product architecture in an insightful way and bringing priority components closer to the disassembly surface are the key to redesign for repairability while minimizing product costs.